Hey y'all, Dr. B here. For this lesson, I want to talk about polynomials. And you'll see the title says polynomials before factoring because I think people jump into factoring and then they don't realize they don't know what a polynomial is. So I wanted to just kind of go over this. So now factoring is all you're doing is taking a polynomial and you literally break it into smaller monomials that you later add together. Now, if you said, what the heck is a polynomial? I don't even know what a monomial is. That's why I wanted to do this lesson, because before you start factoring, you want to make sure you have an understanding of what a polynomial looks like and the different factoring techniques that you can use to break those polynomials down. Now, this is college algebra. You'll see them in other classes, but either way, let's get into it. So these are the topics that I want to cover here. And what I'm going to do is just kind of go through each one and then just provide examples just so you can kind of see it and try to make this a little easier than what you probably think that it is. So what the heck is a polynomial? Well, it's just an algebraic expression, okay? And this is what it looks like. Now, to some of you, this probably looks like gibberish, but when I start showing you some examples, you'll be like, oh, okay, I get it. So it has these are called coefficients, these A's. These are the coefficients, okay? And then this entire thing, these are called terms, okay? All of these are terms. So you end up adding all these terms together, and then that's what forms the entire polynomial. So again, these are the coefficients, these a to the n. These are coefficients or constants, if you want to say that. They are real numbers, so they're not going to be imaginary numbers or anything like that. In order for the polynomial to exist, the one you're looking at, you want to make sure that the first term is not equal to 0, because 0 times anything is just 0. And then you make sure this n is also a positive integer or greater than or equal to 0. So 1, 2, 3, 4, that all that. Okay, so that's what that means. Sorry. So again, these are your coefficients, okay? The entire little piece here that's tied to the variables, those are called terms. And when you add them together, that's what forms a polynomial. Now, ace of n at the very start, or the term with the highest degree, that is called your leading, okay? Your leading coefficient, the number that's tied to the term with the highest degree. And then the degree of the polynomial is n. So if it's x to the fourth, like if it's 3x to the fourth plus 2x squared plus x plus 5, you would say the degree of that is 4. But we'll do some examples, okay? I just want to kind of give you some definitions. And of course, the number that does not have a variable on the end, that would just be your constant term. Now, you notice I have this little star here. The degree of the polynomial is n. So first, before I want to, here's what I want to kind of put a disclaimer. What I want to say is I'll put degree. I'm going to say of the entire largest, I'll put largest term. I try to make it plain. When I do some examples, you'll see what I'm talking about, and I will have some, but let's just kind of get into it, and then I'll make sure to highlight this disclaimer here for you. It's the n degree, but it's going to be of the entire largest term. So whatever the largest, meaning whatever the largest term is, it's going to be, the n is going to be the degree of that entire term. So let's just look at some quick definitions. So you set up a polynomial. We know it can look like this. Well, before you get to a polynomial, you actually have different types of polynomials. So you can have what they call a monomial. And a monomial is just a polynomial with one term. I'll put one term. So for example, x squared, 3x, 5. So they all have one term. It's just one term makes up the entire polynomial. Let's see. You can have a binomial. And again, a binomial is exactly what it sounds like. It's going to be a polynomial with how many terms? Can you guess? Yeah, two terms. So that means two terms make up the polynomial. So if you had 6x squared plus 3x, or if you had 3x minus 5, or I'll just do 6x to the fourth plus 3. It has two terms, okay? That's a binomial. And then, of course, the one that you'll see most often is a trinomial. Most often you'll see binomials and trinomials, but just know each term is called a monomial. So this is a polynomial with three terms. Okay. For example, x squared plus 2x plus 1. That has three terms. 3x squared plus 5x plus 2. That has three terms. Y'all get the gist, right? Okay, so 1, 2, 3, 1, 2, 3. It has three terms. So before we get going, if you see one term monomial, two terms binomial, and three terms trinomial, those are the basics of what you'll see, okay? So now let's talk about the degrees. So remember we said that if I go back, we said the degree is going to be the n, right, of the entire, but I'm putting here the largest term. So let me show you what I'm talking about. So if we're talking about the degree, for example, let's look at, I'm going to put degrees of polynomials. Now that you know all the different types of trinomials, so if you hear me say binomial or monomial or trinomial, you'll know exactly what I'm talking about, okay? So let's look at this one. 3x squared minus 5x plus 4. What type of polynomial is this? Well, you're going to say this is a trinomial because it has three terms, right? And then what is the degree? It's going to be the largest term, right? This is the largest term. And what's the degree on that term? It's a 2. Okay, so you would say this has a degree of 2. See how that works? Okay, what about this one? Negative 4x cubed plus 7x squared minus 11. What type of polynomial is this? This is also a trinomial because it has three terms. What is the degree? We'll find the largest term. This is the largest term because it has a number 3. This would be the second largest, and then this is a constant. Okay, so this is your largest term. Therefore, it has a degree of 3. Easy? Okay, let's look at this one. X squared minus 8, hold on. I didn't like the way I wrote that. X squared, yeah. X squared minus 8x cubed plus 15x to the fourth plus 91. Now, we said what a monomial was, it has one term. A binomial has two terms, and a trinomial has three terms. Well, what do you call a polynomial when it has four terms? You call it a polynomial. Okay? A polynomial, that's just what you call it. Cool beans. Now, what's the degree? What's the degree of this polynomial? Remember, you have to find the largest term. Now, the common or the standard way is writing this in order. Writing it in order like this, where it keeps going down, 3, 2, 1, and the same thing with the constant, like it goes down, descending order. So that's the same thing here. They put x squared, x cubed, x to the fourth, and then the constant. That's not the standard way of writing it. Don't think it's always the first term that is the degree. Find the largest term. This is the largest term because it has x to the fourth. Okay, that is the largest term. So then what's the degree of this polynomial? It has a degree of 4. Y'all see that? Okay. Now, let me kind of throw a little what do you call it? A little, not a tricky one, but one where I want you to see if you can really pinpoint it. So let's do 2 of those. Negative 2x squared y plus xy. And then I'll go ahead and write the last example I have. 7x to the fourth y squared minus 5x squared y squared plus 3xy. And you're probably like, woo, that's a lot going on, right? Well, what type of polynomial is this? Good. It's a binomial. Why is it a binomial? Because it has 2 terms. But you're probably like, Dr. B, it's got like an x and a y as a variable. Yeah, it does, but this is still considered one term. Each term is going to be separated by a plus or a minus sign. Okay, so this is a binomial because it has 2 terms. Now, what's the degree? Some people would say 2, but the degree is actually 3. Why? Because you have 2 variables. So what you do is you still pick the largest, the term with the largest, what do you call it? The largest degree on it. This has a 1. That's an understood 1. So the degree of this term is really 2. This has a 2. That's an understood 1. So the degree of this term here is going to be 3. Y'all see that? That's a 2, and I'm going to put that this is an understood 1. Anytime an exponent is there, that counts as the 1. If there's more than 1, that's when you add a squared or a cubed or a fourth, when there's more than 1. But that constitutes as an automatic 1. So then when you say, what's the degree of this term, what's the degree of the largest term? Now you would say it is 3 because you add them together. Y'all see that? So now with that said, looking at this one, which term has the highest degree? Well, these are ones here, right? If y'all don't mind, I'm going to go ahead and put ones just so we see it. Yeah. So this has a degree of what? 2. Good. This has a degree of what? 4. 2 plus 2 is 4. So this is my largest term then, right? That has a degree of 4 plus 2, 6. Y'all see that? And this is a trinomial because it has 3 terms, right? And it has a degree of 6. Easy? I hope so. At any time, you can leave a question in the comments, but I'm hoping this is making sense. I want to make sure that you understand what a polynomial is before you start factoring. It'll make factoring so much easier, okay? Okay. What can I do with polynomials? Good question. You can add them, subtract, multiply, and divide. All of that and then some. Now, for this particular lesson that I'm doing, I'm only going to look at these 3 because division, it's got a little extra. It's very extra. It's got some stuff, different ways you can do it. But I want to focus really on these because these are the ones that kind of give people the blues, and you'll see this more. You'll see this very sparingly. So for this particular lesson, we're just going to focus on add, subtract, multiply, and divide. So let's work through some examples. So I just got, I think I'm looking at my notes. I only have 2 examples here. So I'm gonna write it right here. So let's do the first one. It is negative 6x cubed plus 5x squared minus 8x plus 9. And I'm going to put it in parentheses just to show that that's my first polynomial. And I want to add that to 17x cubed plus 2x squared minus 4x minus 13. Now, you're looking at that and you're like, oh my goodness, like how am I going to do this? It does look like it's a little extra. Now, what's cool about adding and subtracting polynomials, what you're gonna do, and I'll put it right here. You want to, I'll put for right here, you're gonna combine like terms. Okay, you'll be combining like terms, and you can write it. You can write vertically or horizontally. And you're like, well, Dr. B, what do you mean by that? Sometimes, because with adding and subtracting, you combine like terms. I could have written this just like this. And I could have said plus. Now I'm going to line up all of the terms that have like terms. So I'm going to put the cubes with the cubes, the squares with the squares, the x with the x, and the constants with the constants. So, where am I at? 2x squared minus 4x minus 13. You could write it just like that. And then when you do the math, you add these two, keep the signs, add these two, keep the signs, add these two. See, that would be a minus 8x and a minus 4x, and then add these two. So however you see it, whichever is the easiest way to see it, you can write it either way, vertically or horizontally. I'm going to go ahead and do it vertically or horizontally, excuse me, just because this is math. We go left to right. So whatever. All right, so now when I write this, here's what I'm going to do. I'm going to write it, but I'm going to put the like terms together just so you can see it. So if it helps, what I can do is I'm going to change this second polynomial here to be a different color. Okay, so now we have them in different colors. Now I'm going to add them together. I'm going to add like terms. Okay, so if I'm adding like terms, I'm going to have a negative 6 x cubed, right? Plus a 17 x cubed. Why? Because they are like terms. That this one has an x cubed, that has an x cubed. Okay, let's keep going. Then I'm going to 5x squared plus 2x squared. So 5x squared. And then I'm going to say plus 2x squared. This right here. Trying to keep the colors so y'all can see how the sign is going to follow the number. So I have my x squared terms. Now I'm going to do my x terms, right? So then I have a minus 8x and a minus 4x. You could have written it like that, or you could have written it like, you could have said plus minus 8x. You could have said plus minus 8x. And then you could have said plus minus 4x. Okay. That way, if you want to say you're still adding, that would work also. Okay. So let me put a big or here. You could have written it that way. And then I'm going to add my constant. So I have my 9 and my negative 13. So that's going to be plus 9 and then minus 13. And again, you could have written this as plus 9. And then you could have said plus negative 13. Some people like having the sign right next to the number because it helps you see that you're actually adding or subtracting negative numbers. So what I'll do, so y'all can see that, I'm going to continue with this like this, but just know you can still do this. It won't, it's not going to hurt anything to still do that. So let me bring too far. I'll bring it right here. How about that? Okay, I'll bring it right there. Okay. Okay, I just wanted to rewrite that so you could see that it can be either or, okay? It can be either or. Okay, so let's continue. So I'm going to put my equal sign here. So now, either one, doesn't matter which one we're working through, we're still getting the answer. So now let's start combining like terms. So a minus 6x cubed and a positive 17x cubed. That means you have to subtract 17 from the 6, right? So you should get 11. So since we're combining these, I'll change it to black. That's going to be 11x cubed. Plus, we have a 5x squared and a 2x squared. That should be a 7x squared. Y'all see that? Okay, 7x squared. And then we have a minus 8x and a minus 4x. Or if you wrote it that way, whichever you're comfortable with, that's going to give us a minus 12x because they're both negative, right? So I'm going to put minus 12x. And then we have a 9 minus 13. See the constants? Or a 9 plus a negative 13. Since they're different, we'd have to subtract them. And that should give us what? 9, 10, 11, 12, 13. Yep, so that should be 4. And it should be a minus 4 because the 13 is bigger. Easy? I think so. Cool. Let's do another one. Before we do another one, what is the degree of this polynomial? Good. Degree of 3. Because this is the largest term, so a degree of 3. Okay, let's do, hold on. Do I have room? Yeah, I have room. Let's do it here. My second example. Set 17x cubed minus 5x squared. Interesting. Okay. Plus 4x minus 3. We're going to subtract that with 5x cubed minus 9x squared minus 8x plus 11. All right. Now, what normally gets people tripped up, if you were to write this vertically, okay, if you were to write this vertically, it would be really nice because then you could just line these up and then you would say subtract, and you would, in your mind, you would see that this subtracts this. This subtracts this. This subtracts this. That subtracts that, right? You apply the subtraction to everybody. Well, I want you to do the same thing because when you're dealing with math, they always put things on the same line. So you're gonna see it this way. So what you need to do before you do any combining like terms, let's take the subtraction to everybody, change the sign, okay, distribute the subtraction to everybody so that you can then combine like terms. So let me show you what I mean by that. So I'm going to bring this down. Okay, and then we're going to change this to a plus because we're going to take the minus and we're going to apply it to everybody. Okay, so then that's going to become a minus 5x cubed, right? And then you have a minus and a minus. That's going to be a plus 9x squared. And then you still have a minus and a minus. So that's going to be a plus 8x. And then you have minus and a plus. So that's going to be minus 11. So what we did, we took the minus sign and we distributed it, or we applied it to every term in the parentheses. And when we did that, this became negative, this became positive, that became positive, and that became negative. Y'all see that? The signs became opposite of what they were. And now we have addition. Okay, so now let's go ahead and combine the terms. So we have 17x cubed plus a negative 5x cubed. Y'all see what I did that? And then we have plus a minus 5x squared plus a 9x squared plus a 4x plus an 8x plus a negative 3 plus a negative 11. So you're like, Dr. B, what did you just do? I kept the signs next to the terms. Y'all see that? Here's the minus 5x cubed to put it with the x cubed. Then I had, I'm sorry, this 17x cubed, the minus 5x cubed. This minus 5x cubed is here. Sorry about that. And then I took the minus 5x squared. See, I did plus minus 5x squared. I just put the sign right next to the term. That's all I did. And I did that. I followed that throughout. So now we're going to combine these two, and then combine those two. Okay. So 17 minus the 5, put my equal sign. 17 minus the 5x cubed, that's going to be what? A positive 12x cubed, because the 17 is the bigger number. And then we have the minus 5x squared plus the 9x squared. That's going to be a positive 4x squared. And then we have 4x and 8x. That's going to be 12x. And then lastly, we have the minus 3 plus the minus 11. That's going to be a minus 14. Cool beans. And what's the degree of this polynomial? Good. It has a degree of 3 because this is the largest term. Very good. Very good. I hope this is making sense. Okay, so that's with addition and subtraction. With addition and subtraction, you're combining like terms, okay? Combining like terms. Combining like terms with addition and subtraction. And then you can either leave the minuses out like that, or you can change it to plus and attach the minus right next to the term. Now, let's look at some multiplication. Yeah, let's look at some multiplication. Okay, multiplication. I'm going to put multiplication. Okay, now with multiplication, you got some free reign there because you don't have to combine like terms. You can just multiply different terms. You just have to make sure you add their exponents. So let's go ahead and start with some examples. So here's one. X plus 1 times x squared minus x plus 1. And you're like, well, how do I multiply these? Distributive property. Okay, so take the x times everything, and then come back and take the 1 times everything. So you're going to do distributive property and multiplication property to get what you need. Make sense? Because this is a binomial multiplied to a trinomial. Okay, this is a binomial multiplied to a trinomial. And what are we going to do? We're going to take the x times everything, and then we're going to take the 1 times everything, and then we're going to add it together. Okay? So let's do that. So let's change the color. Okay, color change. So let's do the x times that. Okay, so if I were to write out what I'm thinking, I'm saying I'm taking x and I'm going to multiply it to this, and I'm going to add it to the 1 times everything. That's essentially what you're doing. Okay, that's what you're doing. So now if I multiply this left-hand side, remember distributive property, okay? Distributive property. I get x, how do I want it? Yeah, we'll do it like that, times x squared plus x times x plus x times 1 . Okay, and then plus, it's my black plus, right? And then we have 1 times x squared plus 1 times x plus 1 times 1. You'll see that? All right, so multiplying x times x squared, that gives us x cubed. X times x, x squared. X times 1, x. And then you're going to say plus Ooh, y'all see what I did wrong? I'm looking at it because I'm like, this shouldn't be this big. Okay, what did I do wrong? Let's go back and look. See that? See that? See that? But what happens when I wrote it? Ah, I didn't carry the sign, right? Did not carry the sign. So this should be a minus x, right? Sometimes you get to moving fast with these and you leave a whole thing off, huh? Minus x. Y'all see that? So then this should be a minus x squared. Y'all see that? X times x, gonna give me my minus x squared. And then same thing here. This should be a minus x. Y'all see that? So this should be a minus x. Yep. Minus x squared. All right. Now, because I'm like, this shouldn't be this big. I knew that. I knew that at the very beginning because there was a minus. So I knew something was going to cancel out. Now, combine like terms. A negative x squared and a positive x squared, that's going to cancel out, right? A positive x and a negative x, that's going to cancel out. So we are left with x squared plus 1. Easy? I hope so. Okay, let's do another one. All right. So I'm going to scroll up here. Okay. 2x minus 3 times x squared minus 3x plus 5. Okay. Same thing as we did before. This is a binomial multiplied to a trinomial. Okay. A binomial multiplied to a trinomial. So we're going to do this times everybody and then that times everybody. Okay. Let's get into it. So that's going to be 2x times x squared plus 2x times a minus 3x. Y'all see I wasn't gonna forget that sign, huh? Plus 2x times 5. See, I carried the minus with the minus this time, right? And then let's add that to the 3 times everything. Okay, so plus, and then we're going to have a negative 3, because I got to carry that, right? Negative 3 times x squared plus a negative 3 times a minus 3x. Y'all see that? Carrying the sign, and then plus a negative 3 times, what is that, 5 times 5. I ain't got no room. Okay, made some room times 5. All right, cool beans. All right, big. So now let's just start multiplying. So 2x times x squared, that is going to be 2x cubed. Because remember, you just add the exponents, right? And then plus 2x times a minus 3x, that's going to be a minus 6x squared. 2x times 5, that's 10. Negative 3 times x squared. Negative 3 times a minus 3x, that's going to be a positive 9. And then a negative 3 times 5, that's going to be a minus 15. So far, so good? All right, are there any terms that we can combine? Yes, there is no x cubed, but we have a minus 6x squared and a minus 3x squared. That should give us what? A minus 9x squared. And I already see something I missed. I wonder if y'all see it. Do y'all see it? That? Y'all, it's so real. I tell my students to slow down all the time because you miss stuff, and sometimes I don't get it right, and I just have to keep looking at what I'm doing. All right. Back to the lesson at hand. All right, minus 6x squared and a minus 3x squared, right? That's going to give me a minus 9x squared. And then we have a 10x and a 9x, right? 10x and the 9x. And you're like, where did that come from, Dr. B? Right here. That gave us our 10x. I just magically left the x off. And then this gave us our 9x. Okay, so that's going to give us what, a plus 19x. And then minus 15, that's the only constant, minus 15. What is the degree of this polynomial? Has a degree of 3. I didn't ask you on this one. This one has a degree of 3. And this is a binomial. Okay. That's a binomial with a degree of 3. And this is a polynomial with a degree of 3. Easy? Okay, cool beans. Now, everyone's favorite, the FOIL method. The FOIL method. Now, at the end of the day, the FOIL method is just multiplication. If you don't remember the FOIL method, you are okay. You can still do the distributive property and you can still multiply. When I do the two examples, I just have two examples that I'm going to show you because it's the same method all the time. I'm going to show you, do the distributive property, you'll get the same answer. The same way we were doing the distributive property on these two questions is the same way you can always do the distributive property. Okay, and you just distribute with the first term through everything, then the second term through everything, and you just keep going and you add everything up. The FOIL method, it's almost like a shortcut because you're literally multiplying everything. This is just a different way to show you how to do it. So the F stands for the first term. I'll put the first terms. The O stands for the outside terms. The N stands for the inner terms. Or if you want to say inside, let me say inside. Because they're like inner. Your inside terms of the polynomials. And then the L represents the last terms of the polynomial. So if you have, like, for example, if I can use letters, let me use letters. So if you had, well, let's just do the example, right? Yeah, let's just do an example so you can see what it's talking about. So if you had something that looked like this, x plus 1 times x x plus 5. Let's do that, okay? X plus 1 times x plus 5. X plus 1 times x plus 5. What I normally teach my students to do is to put the letters right above it just so you can remember you're doing the FOIL. But your first terms, if I were to show you what the first terms are, the first terms in this particular example here on the left, your first terms would be the ones that are in the first position of each binomial. This is a binomial, that's a binomial. So it would be x times x. So it would literally be x times the x. That would be the first terms, right? And then the outer terms, or the outside terms, are the terms that are on the outside of the what do you call it, each binomial. Now you'd say, well, this one's the outside. Well, we already did those two. So now we're going to do the x times the 5 because they are on the outside of the multiplications, the outside terms, okay? So that's going to be the x times the 5. And then now your inside terms, which ones are on the inside? These are on the inside of the multiplication. So then that's going to be 1 times the x. And then the last terms, what's in the last position on both of them, is going to be the 1 times the 5. The 1 times the 5, okay? The 1 times the 5. Now, again, if you don't remember the FOIL method, you can take the x times everything, x times x times 5, x times x times 5, and then take the 1 times x, 1 times 5, 1 times x, 1 times 5. The distributive property still works. So until you can get to the point where you memorize this, what it means, do the distributive property. And I just showed you x times x times 5, that's these two. 1 times x, 1 times 5, that's those two. So you're not lost. You can still do the distributive property. And then all you do is once you multiply these, you go through and you add all of these together. Okay? You add all of these together. So let me show you. Put this right here. X times x, that's x squared. X times 5, that's 5x. 1 times x is x, and 1 times 5 is 5. When you add all of these together, you get x squared plus 5x plus x plus 5. Combine like terms. So then you get x squared plus 6x plus 5. This is a trinomial of degree 2. So whether you do the FOIL method or whether you do the distributive property, it's going to work. Okay, don't think you have to do anything different. Until you can remember how it works, be okay with doing the distributive property. There's nothing wrong with that, okay? Nothing wrong with that. Let's do another example doing the FOIL method. So I'll just say this is example number 2. We have x plus 7 times x plus 3. Okay, we're going to do the FOIL method. We're going to do the FOIL method. We're going to do the FOIL method. Okay, ready? We're going to do the FOIL method. First, outside, inside, last. First, outside, inside, and last. Now let me check myself because y'all know I'll be moving fast. So let's see. The first, x times x. The outside, x times 3. The inside, 7 times x. And the last, 7 times 3. Cool beans? Right, so now this is x squared plus 3x plus 7x plus 7 times 3 is 21. Can we combine like terms? Yep. 3x and a 7x. So x squared plus 10x plus 21. Okay, this is a trinomial of degree 2. Or with a degree of 2, however you want to say that. Cool beans? Let's do another one. I think you'll like the FOIL method. But like I said, if you forget, distributive property, okay? Now this one has a minus, so I gotta watch the sign, right? All right, we're doing the FOIL method. Yeah, I got enough room. Yeah, I got enough room. Okay, cool. First, outside, inside, last. First, outside, inside, last. First, outside, inside. Watch that sign. See that? And then last. Don't be like Dr. B moving too fast and missing a sign. So let's check. X times x, x times 3, Negative 5 times x, negative 5 times 3. Cool beans. So that's x squared plus 3x plus minus 5x plus 5. Negative 5 times positive 3 is positive 15. Can I combine like terms? Yep. A 3x minus a 5x is going to be a minus 2x because the 5 is bigger. And we have a minus 15. X squared minus 2x minus 15. And this is a trinomial with a degree of 2. That was sloppy handwriting. Easy? Yeah. Remember, if you can't FOIL or you don't remember FOIL, distributive property until you have it memorized, okay? No shame, no shame. Distributive property always works. Cool beans. Let's look at some other special properties or special operations, whatever you want to call them. These special products will help you when you're doing multiplication. Now, you do not need to memorize these, but because like I said, the distributive property will always work, but they will save you a lot of time. Okay, they will save you a lot of time, but you don't need to memorize them. Just like the F.O.I.L method, if you don't have it memorized, distributive property until you do have it memorized. So the first one is called a sum and difference of two terms. A sum and difference of two terms. So if you have two binomials that you're multiplying together and they have different signs, when you do that, it's just going to be a squared plus b squared. Okay, meaning these terms are the same here. These terms are the same here. Is going to be a squared plus b squared. So like, for example, let me show you. Let's say you have 2x plus 3 times 2x minus 3. Okay, 2x plus 3 times 2x minus 3. If we follow this, they say square the first term minus the square of the second term. So a is 2x, right? So take 2x and square it, and then subtract that from what's the second term? The second term is 3. So take 3 and square it. Ooh. Change the color because I didn't want it matching the purple. All right. If we follow this, they're saying that you don't have to do the distributive property. You don't have to do the FOIL. If you recognize that this, where you have the first two terms are the same, and then the last two terms are the same, and then you have a plus and a minus, it's a difference like that. So now this would be 4x squared minus 9. Okay, let's look at another one. X plus 3, x minus 3. If you follow this property, it says, okay, these are the same terms. These are the same terms. So square the first one, take the x and square it, and subtract that from the 3 and square it. Looks like I picked 3 and 3, didn't I? So then this would be x squared minus 9. Okay, let's look at this one. 5 minus 7x. Oh, this is a good one. 5 plus 7x. Notice the variable has just been flipped, but don't let that confuse you. If you don't remember this, distributive property, right? Or FOIL, or learn this, right? Because you just see it just saves you so much time because you don't have to do the math, or you don't have to do that much math. Let me rephrase that, right? You'll see that. So then 5 squared is 25, and 7 times 7 is 49. X times x is x squared. So the number and the variable are both squared. Cool beans? Easy? Okay, let's look at this one. This is the sum and difference of squares. Sum and difference of squares. Or sometimes they'll say squaring a binomial because these are binomials. Okay? These are binomials. So a sum or difference of squares. So a plus b squared is the same thing as a squared plus 2 times ab plus b squared. And a minus b squared is the same as a squared minus 2ab plus b squared. Now, no confusion here. This means a plus b times a plus b. It's duplicated, okay, because of the squared. And then this one is a minus b times a minus b because of the squared, okay? But for the property, they combine this and they say it's equal to that, okay? Same thing here. This is equal to that. But I want you to know the duplication means it's just multiplied twice. And again, distributive property or FOIL, but if you can memorize that, it will save you some time. So let's look at an example. I'm talking about two. Let's look at an example. So if you have x plus 2 squared, the property says square the first term, 2 times the first term and the second term, and then square the last term. Okay, because it's a plus. So then that means this is going to be x squared plus 2 times x times 2 plus 2 squared. Y'all see that? This matches this property here. Square the first term, take 2 times the first times the second term, and then square the last term. So then you end up with x squared plus 4x plus 4. This is a trinomial of degree 2. Easy? Good. Let's do one with the subtraction. Let's do one with the subtraction. Okay, I have 2x cubed. I said one with the subtraction. Okay, we'll do this one. I have one with the subtraction too. This has a 2 on the term, so that way we can still follow it. All right, so then the property says this is a plus, so we're using this one. Okay, and the property says square the first, 2 times the first and the second, plus the square of the third. So this is going to be 2x squared plus 2 times 2x times 3 plus 3 squared. So 2x squared, 2 times 2 is 4. X times x is x squared. So that's going to be 4x squared plus 2 times 2x times 3. 2 times 3 is 6. 2 times 3 is 6. 6 times 2 is going to be 12. So that is going to be 12x. Or you could have said 2 times the 2x is 4x, and then 4x times 3 would be 12, and then you have plus 9, because 3 times 3 is 9. This is a trinomial of degree 9. So far, so good. Make sure y'all can see the minus. There we go. So now let's do a minus one. X minus 3 squared. The minus says that the minus gives you a squared minus 2ab plus b squared. So if we just follow the property, it's going to be the first term squared minus 2 times the first term times the second term. See how I kept the minus with it? Keep the minus with that 3, okay? Oh, not like that. Sorry. The minus is here. Don't keep the minus with the 3. Ignore that. You know why? Let me show you why. You don't keep the minus with the 3 because the minus is right here. You see it? The minus, this is this minus here. So you don't need to pull it with the 3. Just follow the format. Follow the format. Sorry about that. and then plus the last term squared. Yeah, follow the format on these, because even when you do the FOIL method, it works out that way too. So follow the format. So that's x squared. That's minus 2 times x is 2x times 3. That's going to be a 6x. And then 3 squared is going to be 9. That is a trinomial of degree 2. Easy? Okay, good. This is a sum and difference of cubes, a sum of difference of cubes. You notice it's kind of similar to the squares, but these work with the squares. Okay, and so now we're doing the sum and difference of cubes. It's a little bigger. Now, this right here, this does mean a plus b times a plus b times a plus b. So if you don't have this memorized, you could still do this. You would just multiply these two first. You would end up with the trinomial, and then multiply this last one to the trinomial. Okay, and then same thing for this. This does mean a minus b times a minus b times a minus b. That's exactly what that means. You would multiply these two first, and you would end up with the trinomial, and then you would multiply that trinomial by this last binomial. Okay, so this one is a little harder to memorize, but if you can memorize it, it will save you time. But for the sake of our time, let's do some examples. I got two examples. So x plus 1 cubed. I'm gonna follow this. Okay, follow it exactly out how it has it. It says I need to cube the first term and take 3 times the first term squared times the second term plus 3 times the first term, then times the second term squared, and then plus the second term cubed. And you're saying, well, Dr. B, what are you calling terms? This is the first term. That's the second term. Okay? First term cubed, 3 times the second term squared times the first term, 3 times the first term square the second term, and then the second term cubed. Y'all see that? So this is x cubed. This is 3 times 1 times x squared. 3 times x times 1 squared. And then 1 cubed is just 1. Easy? This is a polynomial of degree 3 because it has 4 terms. So we just call it a polynomial. Okay? 4 terms, and we just call it a polynomial. Easy? I sure hope so. Okay, let's do one with the subtraction. And after this, we're going to do some, I call them oddball situations that you'll see. And I call it just for grins. We'll just do them just in case you see them. Okay, let's follow. We're following this, okay? Follow the property. Follow the property. So the first term cubed minus 3 times the first term squared times the, look, I almost did it. Follow the pattern, just times 3, because this subtraction here is the same as that subtraction there. So you don't pull the sign. Don't pull the sign. Don't pull sign, because the property does it for you, okay? Now, if you were doing distributive property, absolutely pull the sign. But if you're following the property itself, then do it, okay? Plus 3 times the first term times the second term squared minus the second term cubed. x3, x3, yep, okay, cool beans. So that's x cubed minus 3 times 3 is 9 times x squared, 9x squared, plus 3 times x times 3 squared. So let me write this here. 3 squared, we know that's 9. Okay, so then you have 3 times x times 9, and we know that 9 times 3 is 27. Okay, so that gives us plus a 27 x, and then 3 cubed. That's 3 times 3 times 3, which we know 3 times 3 is 9, so that's 9 times 3, and that gives you 27. One of the things I want you to notice on all of our answers, notice the powers or the exponents go in descending order. That's the proper way to write these. So whatever software you're working in where you have to enter your answers and they say like a standard form, you want your variables to go in descending order. 4, 3, 2, 1, 3, 2, 1, 2, 1. They always go in descending order. Okay, that's the proper way to write these. Cool beans. Let's do some oddball ones that you might see. Just some ones that you might see. I picked 3 of these just because they look kind of unique. So here's the first one. I have 5x squared y minus 3xy, and I'm going to add it to 2x squared y minus xy. Now, can these be added together? Can these be added together? Yes, because you have a 5x squared y and a 5x squared y. Those are combined together. And then you have a xy and an xy. So you can combine like terms. So if I were to write these with the terms next to each other, that would be 5x squared y plus 2x squared y. And then plus minus 3xy plus a minus xy. Why can I do that? Because these are like terms: x squared y, an xy, and an xy. The constants don't matter when you're combining like terms. It's the terms that matter, okay? So those do work. So when I add those together, I get what? The 5 plus the 2, that's going to be 7x squared y. And then a minus 3 and a minus 1, that's a minus 4. See that? 7x squared y and a minus 4x squared. Do you remember what I said about the degree? It's of the largest term. These are understood ones here. This has a degree, this by itself has a degree of 2. This has a degree of 3, which is the largest term. So the entire binomial, because there's 2 terms, has a degree of 3. Cool beans? Cool. Let's look at another one. And again, I picked ones that were kind of oddballs, okay? Kind of oddballs. Woo. This is getting good. This is getting really good. Okay. This one is 7x plus 5y squared. 7x plus 5y squared. You can do the FOIL method. Now, I did this one because it's very tempting for people to say, oh, this is 7x squared plus 5y squared. But that's not right. You cannot distribute this inside. The only things that you can distribute is when there's a minus on the outside, you can distribute that way. Or if there's a number on the outside, then yes, you can distribute. But when you have exponents, exponents tells you how many times that whatever's in the parentheses exists. So this is really 7x plus 5y times 7x plus 5y. Y'all see that? 7x plus 5y times 7x plus 5y. 7x plus 5y times 7x plus 5y. So, and then another thing people say, oh, is this the sum and difference of 2 terms? No, because these are both sums. In order for it to be the sum and difference of 2 terms, this would have to be minus, and it's not. And then you say, oh, well, are we squaring? Are we squaring a binomial? Well, sort of, But whatever your, what do you call it? What am I trying to say? Yes, but if you don't remember that it's a squaring of binomial, you can do the F.O.I.L method. That's what I was trying to say. You can do the F.O.I.L method, but this is the squaring of a binomial. Let me write that for you. Remember, if it was a plus b squared, then they said you take a squared plus 2ab plus b squared. But I'm going to be honest with you, sometimes when you see this, you don't automatically see that you're squaring a binomial. So the default is the F.O.I.L method. And the default to the default is the distributive property. 7x times the 5y, and then 5y, and then add everything together. Okay? One half dozen the other. Just pick one that you're very comfortable with until you memorize these properties. Just do the math, okay? Do the F.O.I.L is what I'm saying, or do the distributive property. So let's come down here. I'm going to follow the property. So my a is 7x. My b is 5y. Y'all see that? And that's what I'm saying. It kind of saves you some math. So 7x times 7x is going to be 49x squared. 7 times 2 is going to be 14x. And then if you're going to say 14 times the 5, putting that in my calculator, that is 70. 70xy, because you still have the variable, see? And then 5y squared, 25y squared. 25y squared. This is a trinomial of degree 2. Trinomial of degree 2. If you look, that's a 1, that's a 1, and this has a square. So it's of a degree 2. Cool beans? Whew. All right. Do I have room here? I do. Now y'all check this one out. You might not see these too often. They try to sneak them in on you, but I think y'all might get a kick out of this one. Let's see. Y'all are probably like, we don't get a kick out of none of this math, Dr. B. So quit playing, right? Okay. 3x plus 4y squared minus 3x minus 4y squared. All right, y'all. What are we working with here? What are we working with here? Now, remember, you cannot distribute an exponent. That's not how the exponents work. You cannot distribute an exponent. That's not how exponents work. Well, you said, Dr. B, we could distribute the minus. Well, you only can distribute the minus when you've already taken care of what's in the parentheses. So when you follow order of operations, it's parentheses, exponents, multiplication, division, addition, and subtraction, right? Well, you can't distribute this yet because this needs to be squared. So you have to take care of the square first. Now, let's say you don't know any of the properties. If you don't know any of the properties and you know this means duplicate, this is what I would do. And I would put this in a massive bracket just so I show my two pieces. Okay, I put it in brackets because I want to show that this has two parts and they're subtracted. All right, now what do you see? There's properties, but I just want you to see. You can FOIL this, right? You can do the distributive property. You can FOIL this and do the distributive property. And then after you do that, you can distribute the minus to everything. If y'all want, let me go ahead and do that. And then I'm going to show you the properties. I'll do it the long way, and then I'll show you the shortcut because this is the last example that I have. So let's do the distributive property. Okay, so I'm going to take 3x times 3x, 3x times 4y, 4y. You know what? I'm going to do the FOIL because I'm hoping by this point you remember FOIL. So let me just put FOIL up here. And then I'm going to show y'all the property. Because then you're going to be like, oh, bet. If you know the properties, hopefully whoever your professor is, they let you have a formula sheet. Okay, first, that's going to be 3x times 3x, right? And these are going to be the same color in this one bracket, okay? And then the outside, 3x times 4y. The inside, this is going to be long. Okay. 4y, the inside. And then the last, which is going to be 4y, 4y. Okay, I'm going to do top and bottom just because I'm running out of room. So this is minus. That's the minus sign. And then now let's do this right-hand side. So the first, the outside, minus 4y. The inside, minus 4y. And then the last, minus 4y, minus 4y. So far, so good. Okay, let's move this to the next page. Okay. Then y'all are gonna see, oh, the properties are so much better. Yeah. Okay, so let's do this first one here. So that gives you 3 times 3, that's 9x squared. 3 times 4, that's 12xy. 4 times 3, 12xy. And 4 times 4, 16y squared. Do y'all see that? 9x squared, 12xy, 12xy, 16y squared. And we're still subtracting. We're still subtracting, okay? Don't forget, we're still subtracting. So now we have 9x squared minus 12xy, or I'm going to say plus a negative 12xy, plus a negative 12xy, plus a positive 16y squared. 4 times negative 3 is going to be the 12. So that's where we're getting the negatives. Okay. Cool beans. So let's keep going. So the top now, and I'm doing this the long way because I want to show you why the properties really help. So then the top one, we have 9x squared, 12x, that's going to 12 plus 12 is 24, xy plus 16y squared, right? Minus 9x squared minus 24xy, because a minus 12 and a minus 12. And then you're going to have plus 16y squared. Okay, now we're going to distribute this minus sign to everybody. Okay, so then we have 9x squared plus 24xy plus 16y squared minus, matter of fact, I'll go ahead and put minus 9x squared plus 24xy minus 16y squared. We took the minus to everybody. So this was positive, it became negative. This was negative, it became positive. This was positive, it became negative. Now we can combine like terms. 9x squared plus a negative 9x squared, because I can say plus a minus. 9x squared plus a negative 9x squared That's 0, right? If it helps for me to write them side by side, I will. 9x squared plus a negative 9x squared plus 24xy sorry, plus a 24xy plus a 16y squared minus a 16y squared, or plus a negative 16y squared, however you want to write it. All right. 9x squared plus 9x squared, that's 0, right? 24xy plus 24xy, that's a 48. These were all equals. And then a 16y squared and a plus a minus 16y squared, that's 0 too, right? So this is our answer. This is a monomial of degree 2. Why? Because these are understood ones, right? You're like, my goodness, we did all of that just to get to that? Let me show you something. Let me show you something. Let me show you something. What properties do you see? Do you see any properties? Yes. Say, yes, I do. Say, yes, I see some properties. Let me show you. This is A plus B squared, right? And this is A minus B squared. Y'all see that? And they're subtracted. So do you remember our properties? Let me get those. Okay. These are our properties. These are our properties. So let's follow what it says. Okay, with the green, that means 3x squared plus 2 times 3x times 4y plus 4y squared minus 3x squared minus 2 times 3x times 4y plus 4y squared. Now I'm going to distribute, well, let's simplify and then we'll distribute. Okay, so then that's 9x squared plus 6 times 4, 24y plus 4y squared minus 9x squared minus 24y, 16y squared. I paused because y'all know that ain't right. Ain't nobody, y'all didn't say nothing. That wasn't right. Now it's right. You gotta square the number and the term, right? Okay. So now we're gonna distribute the minus sign to everybody. Okay. So we have 9x squared plus 24y plus 16y squared plus a minus 9x squared plus a 24y minus a negative 16y squared. And you say, why is the 24 positive? Because we did minus to minus. Okay, so that became minus, that became positive, and then that became minus. All right. Now we can combine like terms. I will put the like terms together. So we have 9x squared plus a negative 9x squared. If y'all haven't learned by now, I like to show all of the steps, because if you know the steps, then this doesn't hurt you. But if you don't know the steps, I don't want to leave you behind. So that's why I write out all the steps. So those of you that get tired of that, too bad. We want to bring everybody along, okay? So now that's gone, right? Was that 48? But what did we do wrong? Y'all see what we did wrong? I'm going to keep going and then y'all tell me what we did wrong. And then this right here. I always see it after. I think this has been a long lesson, so I'm getting tired. Those cancel out too, right? What did we do wrong here? What did we do wrong here? You see, it's very easy to leave off terms. Very easy. What did we do wrong here? XY. Y'all see it? XY, 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 XY. It's very easy. Very, very easy to leave off terms, especially when you're tired, right? Okay, so let me fix that. XY, 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 XY. XY. This is the last problem, right? Thank goodness. Okay, so we getting tired, boss. All right, so this is all we have left. So that's going to be a 48 XY. So that's where I'm talking about the properties save you, because if you notice, this was our work here by using the two properties, but this was our work when we didn't use the two properties. We started here. Okay, we foiled that, we got this whole thing minus this whole thing. Then we wrote out all the terms that we needed so we could see all the steps. Same thing here, we combined like terms here. Then we were able to distribute the minus and put it together. But when we used the properties, it took us straight to this part here, which saved us a lot of time. Remember, if you don't remember the properties, distributive property will work, the F.O.I.L will work, you'll just do more math. But if you can learn the properties, or you have a professor that allows you to have a sheet of all of these properties, it will make your math so much lighter. All right, y'all reach out wherever you have questions. I hope that this was helpful. Let me know in the comments if you need to see any other type of special scenarios that you want me to work out, and I will be more than happy to do that. Thanks, y'all.